I didn't test them. So, yeah, they work.
Hi everybody, it looks like this room's going to be oversubscribed again. If there is a gap next to you, could you please move to the middle? Thank you.
Thank you. Okay, to be honest, I have no clue if we're live or not, because I think I'm supposed to have someone here. So, I don't know. Go? All right, let's go. Okay, so we're going to talk about service discovery today, and we'll focus on the client side. How do you use service discovery in Python? I won't argue if you should or not use this service discovery in this talk. I won't explain how to install the three technologies that I will cover here. I will just focus on their usage. And if we have time, which I hope we will have, I'm crazy enough to have done a live demo. So we'll try it. Thanks. It's an opinionated talk, okay? So that's my point of view here. Short introduction about me. You can find me on the Nick Ultrabug. I'm a Gentoo Linux developer where I work mostly on cluster stuff and Python stuff. I maintain packages related to NoSQL, key value stores, or message queuing. I'm also CTO at Numberly. We are a programmatic and data-driven marketing and advertising company. We have a booth over there with a quiz, and you can win some crazy stuff, so just come around and we can have a talk. Okay, so what is service discovery? To make it short, you can compare it to what DNS is for your browser, but in a dynamic way. When you connect to a website, your browser first have to find out the IP address of the host hosting the website you want to reach. And to do so, it does a DNS query. Beforehand, when you own the web service and the website, you had to configure the DNS and register inside the IP address of the server, of your server. Service discovery is about the same thing. It's about registering and querying, but for a service. That's the basic of it. Let's see a bit more about it. So we have a catalog that's provided by the service discovery technologies. Then you have your servers. Each of them provide a service. Some of them provide the same service. They will register themselves into the catalog. And so you will get a list of service is running at host and port multiple times if the service is running on multiple servers. Then you have clients. The clients will be looking for a service by its name, usually, and they will query the catalog for the given service, and they will be handed over a list of available hosts providing said service. This is service discovery. Now let's take a quick tour of the three technologies I will cover here. The first one is the oldest one. It's named Zookeeper. It's from the Apache Foundation. Zookeeper is firstly designed as a reliable cluster coordination. It's used mostly and mainly in Hadoop. It has some pretty interesting features, and it's mature since it's the oldest of the three technologies we'll cover here. When I say in the negative points that it doesn't provide service discovery per se, that's true, but we'll get back to it later as to how we can still use Zookeeper to achieve service discovery. What I mean by this is that it's not a built-in feature of Zookeeper. The main design of Zookeeper, and it's the same for etcd, which we'll see just after this, is that you can compare them to a distributed hierarchical file system, which is also comparable to a key-value store. You'll see about it. It's written in Java, and it uses a special implementation for consensus algorithm. The consensus is about making sure all the nodes of the Zookeeper cluster agree on something. The Python C bindings are not usable. There is one provided here on the sources, but it's not really usable, and even worse for service discovery. It's not a data center aware technology. It just knows about its own cluster. Now you have etcd. etcd is from the CoreOS guys. It's a pretty recent project. It's written in Go. It uses the Raft consensus, which is pretty robust. It has a good adoption. It's used on many bigger projects like Kubernetes. And it provides an HTTP API to do all the queries and registration stuff. It's pretty simple, really simple to implement and configure. Just like Zookeeper, it doesn't provide per se a service discovery mechanism. But we will use the file system hierarchy to achieve this. It's not data center aware either, and it doesn't provide any kind of health checking of your services once you're registered. We'll see about it later as well. The third one is Consul. It's from HashiCorp. That's the newest of the three. It's also written in Go. It's also using the Raft consensus algorithm. And yeah, I told you it's an opinionated talk, so I didn't find any bad things to say about it, because it has built-in service discovery feature. It's data center aware, so you can have multiple clusters of consoles in each data center, and they can talk about them between them. And it also provides a DNS API, so you can also look up for services using DNS, which is kind of a good feature. The note I wanted to stress out on Zookeeper and etcd is that we will achieve service discovery by abusing the key-value store. You can see the key-value store as a sort of file system where you can store data. Registering is about creating a node or a folder or a file, if you want to relate it to your local file system, and make it meaningful. In this kind of example, at the root of the hierarchy, I will say, okay, the first level will be my service name, APA-X. Then, on the second level, I will create a folder which will represent all the servers providing this service. So I call this folder providers. And then inside, I will create nodes, or you can relate it to files, which are named my host, 2 points, and the port. So discovering providers for APA-X service is just like listing the content of APA-X/providers directory. Fine? We can do the same with memcache and stuff like that. That's how you can abuse and achieve service discovery using key-value store-based technologies, such as Zookeeper and etcd. Okay? Okay, now let's see the Python clients library to talk to each of those technologies. The first one for Zookeeper is Kazoo, ZCZK, and yeah, I know. I'm sorry about this. We can be a very creative community, I know. We'll use the underscore line 1, ZCZK, which underneath uses Kazoo. So you can see a wrapper, ZCZK as a service discovery-oriented wrapper of Kazoo. So it's pretty handy. Then for etcd, we have some standard Python-etcd library, which is pretty good. If you use async.io, you have another for async.io stuff as well. And for console, you have Consulate and Python console. We'll use Python console, which is more now documented and more active than Consulate. Last year, it was the contrary, but this year, Python console is very, very nicely implemented now. So good job, guys. Thank you. Okay. When you choose a technology, you have to rely on it. Even more when it will be the core of your whole topology. You have to make sure that you can rely on the Python clients because they really have a direct impact on your application. So let's see about the ZCZK client library, which uses Kazoo. When you want to connect to a Zookeeper cluster, you can specify multiple hosts, which is pretty cool. It has auto-reconnect feature. You can query about the connection state. You will get connected or disconnected and stuff like that, so you can have your code handle this gracefully. And it has rich exceptions if something wrong happens. So I'm providing a quick example here. The don't fail on connect means if no server is available, when I do the first line and wait and try to connect to my Zookeeper cluster, will it be blocking? Will it raise an exception? In this case, it's blocking. And you can change this with the wait parameter, but it will raise an exception. Okay? So it's not for the one of you who are used to the Python memcached library. You have to know about this and handle it because it can block your whole application if no Zookeeper server is up. On the etcd side, Python etcd side, you don't have the possibility to connect to multiple hosts, but you have auto-reconnection gracefully, so it's pretty good. You can't really try and get the connection state. The exceptions are pretty rich, so you can see what's happening pretty easily and catch the good exceptions about the different kind of errors that you can happen to be running into. And it does fail on connect. The Python console one is, well, not so good as the ZCZK one as well, because it doesn't support multiple hosts either. It has also a reconnect feature, auto-reconnect feature. The exceptions are so-so. I'm providing an example here. Connection error is, well, sometimes not very, very meaningful. But it doesn't fail on connect. That means it's non-blocking. You just create your console client and then continue on. Nothing happens when you do that, which can be a good feature. Okay, now about the service registration. There are three things you have to consider here. Three states of a service lifecycle. It's getting up and it needs to register into the catalog. Then it's running and you have to make sure it's still running. Because if it's not running, it crashes or your server providing said service becomes unavailable. You don't want to answer clients about it. Okay? So you have to remove it in a way from the catalog when it's down. That's the dynamic part. And then if we stop gracefully or if we crash, we have to deregister it from the catalog. So the health checking will also do the deregistration for you in case of failure. We'll see how it's done on every Python implementation. For ZK, it's pretty straightforward. The main thing to understand is the first one over here, the first try except, will just create the file system hierarchy I talked to you about. So we just make sure that we have the /EP 2016 providers, and we do a make path that will create the whole path like a mkdir -p. And if the node already exists, it's okay, we can continue. Then the ZCZK provides a cool method, which is register, and then you say, okay, on this node, on the provider's node, I will register a machine named Yaz running on port 5000. And it will create the file like node, like Yaz 2.5000 for you. Okay? That's all you have to do. Now, about health checking. The health checking in Zookeeper is implicit because Zookeeper has this cool feature named ephemeral node. An ephemeral node is just like that. There are like files or nodes in the file system hierarchy that are present on the file system as long as the session of the client who created them is alive. So whenever the client dies or closes its session, Zookeeper will know about it and will remove the given node automatically. So it's a good way of doing health checking, because if your application crashes or you want just to deregister, you just have to exit gracefully and close your session. By closing the session to Zookeeper, Zookeeper will remove all the nodes you created with this application. So the register thing does that. It creates an ephemeral node. So that's implicit in the ZCZK Python client. What about the failure detection latency? If my program is kill-9 or crashes badly and didn't have time to deregister gracefully, how long will it take for Zookeeper to remove the node from the hierarchy? And then, in other words, how long will it take for the clients to not be served my host and port anymore? It will take session timeout here. When I created my client session, I said 5. So it would take up to 5 seconds, in this case, to make this happen. So for 5 seconds maximum, I could be serving wrong host and port to my clients from the catalog. That's something you have to consider as well in such topologies. On etcd, it's basically the same principle. We try to read the provider. If we can't find it, recreate it as a directory. Then we just have to write. There is no register wrapper or something like this, so we just have to write the given node I'll talk to you about here, and we can set a data in it, so we'll put also the same thing in the value. It's not a directory. And it has a time to live, TTL, which I'll talk to you right now. That's the health checking, actually. You can see that it's coming difficult here. Why? Because etcd doesn't have the concept of ephemeral nodes as Zookeeper has. That means that you have to implement health checking yourself, or use a third-party library or program to do it for you. But you have to do it yourself. So in this example, I'm doing it myself. So the trick I'm using is that when my application starts, I have to create a health pinger thread, which will constantly and in an infinite loop register my service, and that will be a sort of heartbeat or health checking stuff with the TTL. And then my TTL, the time to live of the node I'm creating, it will be removed after X seconds, TTL seconds, from the hierarchy. So my failure detection latency is TTL. But I have to have a thread constantly making sure that my node is present, and so my service and server is in the catalog. Okay? If you use console, everything is granted and built in. So you can see in the code that it's pretty straightforward. I just have to register my service into a console agent, which is as well very self-explanatory. The name of the service, the address of the host providing it, and the port it's running on. It's integrated, nothing more to add. The health checking is interesting in console because you have a way to make sure that the console servers will run some health checks of your service by themselves. So you just have to create, like in my example, it's an HTTP service. So I'm creating an object, a health check object, which is of kind HTTP, and I'm providing the URL that the console server should call every 2 seconds. So I'm telling console, hey, okay. And when I register, I pass the extra argument check, and I said to console, okay, check this URL every 2 seconds. If it fails, remove me from the catalog. Or, to be very correct, mark me as failing. All right? How do you discover all of this? It's pretty straightforward as well. So I will just show you the querying part. For Zookeeper, you can get the addresses by listing the children of the given node. So I'm listing the children of the providers folder in EP 2016, and that will be my nodes. I just have to loop over them, split the 2 points, and I get the host and port of every server providing my service. Okay. etcd, basically the same stuff. So you make a recursive query, a read, you get the children, and you split, and you get your host and port. On console, it's also very easy. You query the health service, because you want only to get the healthy servers providing your service. So that's the passing equals true here. I just want you to return the service where the health check is passing, the servers and ports for which the health check is passing. Okay? And then inside I get a lot of information. It's a directory style thing. And inside there is the host, port, and other stuff, interesting stuff. Sounds good? Okay. Now, let's play. So, I have given 3 Raspberry Pis, and my machine here is running a Zookeeper, etcd, and console agent. So, the idea I had is to showcase a service discovery page like this, where we will be looking for the EP 2016 host, providing we'll be looking for the host providing the EP 2016 service. So I just wanted also to demonstrate, it's here. To demonstrate the key value storage, which all those technologies are also used to configuration access. So you can store your configuration in this key value stores. So your application can also get them from it. So the color here, I don't know if it's readable because of the resolution. Yeah. Every time I reload this, I change the color configured on each in Zookeeper, in etcd, and in console for my web service. So Dirk, can you start running your Raspberry Pi? So Raspberry Pi 4 is this one that I plugged in a few seconds before, and I can just go to it like this, and you can see that every time that I will change the color on the key value store, it will be picked up by the application from, in this case, Zookeeper. And then Dirk just plugged in the Raspberry Pi number 1, which appeared and got discovered here by the server on every platform. So if you also plug in yours, and you too. So we'll see the others coming. And what's interesting about this is also like this. Okay? It's going to get hard now. I think my Raspberry Pi 4 gets a bit overloaded here. That's the Wi-Fi, but it's okay. So each time I reload, okay, Dirk Raspberry Pi is running pretty awesome. You see that my Raspberry Pi 4, which is not responding here, you can see that it's not responding. The health check failed for every one of them, and that it has been removed from Zookeeper, etcd, and console. So it's a good thing, okay? It's working. Right. Okay, so now we can see Raspberry Pi 2. Okay, Raspberry Pi 4 is getting back somehow. It's getting back. Yeah, it's getting back, okay. Raspberry Pi 3 on console, yeah, it's working as well, okay. You can't see the color now, all right. Yeah. So now we have the 4 Raspberry Pis up and running, and they seem to be, pretty stable on the health check. Yeah. I will disconnect Raspberry Pi 4. Now let's see about the time it takes. It depends on the technology, because they have a different kind of TTL, ephemeral node session timeout, or health check timeout, okay? All right. Yeah, some of them are overloaded. Do you have any question? Yeah. I don't know. Yeah.
I'll try to speak up. How does load balancing fit into this picture? What I mean is that if you have one service running on two different hosts,
Yeah.
both of them announce themselves to the catalog. Should the catalog give only one node to a client, or should client decide?
The client decides. So the question is there any kind of load balancing? No. The catalog, when your client queries the catalog, it gets a list of all the available nodes for the given service. That's all. Then it's up to you to decide to which one you want to connect.
Yeah, I have a question about redundancy. If you have an application that is dependent on the service discovery catalog, and for different services that exposes, and the catalog for some reason crashes, how will you recover from that situation? Will you have like service discovery of the service discovery, or how would you do that?
Yeah. No, you don't do service discovery or service discovery. The minimum that's advised of servers is 3. So you should have at least 3 Zookeeper or console servers running. Okay? So if you want more resiliency, make it 5, 7, but an uneven number. Okay? Always an even number. If something very bad happens and you don't have service discovery anymore, I guess you have to handle it on your application side. You can make it like with caching stuff. It's not very easy, and really depends on the type of application you're running. But the best course is to make sure your service discovery cluster has enough nodes to sustain this kind of problem.
So you would put the service discovery nodes into a cluster and, for example, register them in a load balancer or something too?
Well, it depends on the technology, actually. As you saw, if you use Zookeeper, you can connect to multiple hosts. So you don't need a load balancer. You just put every of the node in it. On the other hand, in console and etcd, you have to specify one of the nodes. So maybe you can implement some kind of stuff on your application to handle this, like having a DQ or something like this in Python, and try again in each exception. If it raises an exception, you can try and connect to the other host, etc., etc. Yeah.
A question about.
I think for the recording. Yeah. Sorry.
A question about registration procedure.
Yeah.
Why don't you want to use external tool to do this? It can be implemented in configuration management, Chief, Puppet, Salt. And in this case, you will have a possibility to register third-party services like MongoDB and so on automatically.
Mm-hmm.
So that's the question. Why not do this as external service for your application?
Well, I think, to me, Chef and stuff like that are good for provisioning or configuration, really configuration, applying configuration to servers. I don't see service discovery like this. To me, it's more, I relate to your point with MongoDB and daemon stuff like this. You have external programs that do it for you. I'm not sure that, for instance, Chef, etc., can have health checks running on. So if you make it with etcd, it may become difficult to do. There are a lot of third-party libraries doing it for etcd, for example, because it has a wide audience, and for container stuff like this, they use specific third-party tools, but not provisioning tools.
Yeah. Well, we are using a register container that automatically registers any container that is running on Docker host, and it's very good idea. I think it works well, and it's if something happens with container, it will be deregistered automatically.
Yeah, but it has to be registered somewhere, anyway.
Yeah,
so
we are
having
running,
a service.
We are running local agent on each host machine, local console agent, and each service knows that it can find agent on local host, and only agent knows where there is a console cluster located, and it can be implemented in very easy way. External stuff.
But you don't have central configuration place, or you do it also in.
We are using Salt to install everything, but actually service discovery is implemented using special containers.
Okay. No other question? Well, thank you. Have a nice day.
what's the thing about goats?
About goats? Yeah, it's explained in the book. Did you read it?
No, I just was skimming through it and now it's in my book reader. So we just moved to PyTest and those and everything.
Oh, it doesn't. We don't use Python or in the book. But the goats. There's a thing called testing law in Python in the US. Where people would get together and do lightning talks all about testing. They were quite fun because it was everyone was drunk. So it was like lightning talks all the time. Then one day they all got out. Maybe not. But people used to have like funny slides with pictures of cats, and then eventually someone went like, fuck cats. So it's just that they said, so we need something else for the testing, and let's have goats. And so they put some goats in and started calling it the testing app. And that was a thing, like there was a short meme and it almost died, and then I heard about it. So I thought, I'll put it in my book, I'll have the testing goat, it'll be a real character.
It's a book about animals.
What time do you start?
11:15. Yeah.
It's a half an hour slot. It's 30 minutes?
45.
45?
Yeah.
Whoa!
It's very long, or I intend to do 35 and then leave 10 minutes for...
Okay, that's good. So if it's a 45 minutes slot, you have 40 minutes. So if you want to leave 10 minutes for questions, you have to do 30 minutes of talking.
Okay.
Or 35,
right.
fine.
I'm going to try to go fast.
No, I mean, no, just relax. So you can, if you have planned 35, you can do 35 and 5. If you want, you can do 30 and 10.
I have to improvise because I have a shitload of...
Lots of stuff?
I don't know, because I don't know the audience. It depends. I don't want to get too technical. Yeah. I don't want to be so abstract. So I want to respond in a more...
When you practiced it, how long did it take?
Practice? Not that kind of person.
Right? So it's up to you. Whether you think it's more interesting to have questions or you just want to get through
I want to have questions.
Yeah.
But I know what's the middle point of the presentation, so I can speed up
Okay.
when we are like half.
Okay, cool. So I'm going to show you the 15. 15 minutes.
When we are in the middle.
Yeah, that's halfway. And then you get 10, 5, and even 1. And if you find you're getting to like the end and you want to overrun, you'll have 10 minutes. So there's lots of time.
Great.
Check, check, check. 1, 2. Did you know that the 11:15 slot in the second largest room in the conference is always the best talk? That's an absolute fact. Come in, everyone. Welcome. This is mathematically certain to be the best talk of the whole conference. Just wondering, come towards the front. If you come closer to the front, the speaker feels that you're more engaged with their presentation. When the speaker feels that you're more interested, they're more confident. When they're more confident, they give a better presentation. When they give a better presentation, you learn more and you're happier. You're happier, they're happier. It's just a virtual circle of wonder. Okay, 2 more minutes by my count. What time does everyone else's watch say? People have been accusing me of having a watch that's not correct. Mine says 11:13. What? 14. 11:14:44. 48. Christ, it's moving at 1 second per second. Make it stop. All right. In that case, it must be 11:15 in about 10 seconds. So without further ado, please give a big hand to our next speaker who will be talking about encrypted email.
Hi. I guess you can hear me right. Welcome. Buenas, egunon. I guess you are not in the wrong talk. We are here to talk about encrypted, privacy-oriented services, especially email. I'm going to confess something. I just finished the slides 10 minutes ago. So this is my practice. A little bit of history. We are in a very interesting place. We are going to talk about old protocols. I'd like to introduce some history about the places where we're in. This was a shipping company, a shipping factory that started in 900 and ended in 1984. when I discovered that on the Wikipedia, I said, wow, this is a really good omen to talk about privacy. In the riots with the police, one worker was killed here. By the way, the slides are in here, and many of those things are links, because I don't want to get too technical. I am here more interested about talking about tools. This is the Carola crane out there. We have the whole year, we have IRC, we have mailing lists to discuss about technical details. Actually, I'm merging two talks. Holger Krekel, I guess some of you will know it, I just met him 2 months ago. Was going to give another talk about towards secure email. And for personal reasons, he couldn't make it. So I decided to put together some of the conversations we are having and try to merge the talk. So I'm intending to do two different parts. One more about high-level philosophical questions, if you want, and strategy, because we are a community that build tools. And the other part is about actual tools. So I work in something called Leap Encryption Access Project. We gathered like 4 years ago to decide to make encryption accessible. My role in the team is this. I'm probably not the best person to be here giving this talk, but I was just passing around Europe and nobody else could come. So forgive me for my ignorance. This is my first talk in kind of a serious manner. I started doing Python 10 years ago, but this is the first time I'm actually trying to present something to the world. So, Leap, what do we want to do? We want to make privacy usable at all levels. And the motto is we kind of feel that we have to defend the right to whisper, because privacy is about the right to whisper. Some of the really smart guys that started this project are coming from these kind of collectives. Someone here has a RiseUp account? Good. RiseUp is a tech support collective that gives support for activists. It's like the Gmail for social movements. And this is a problem, because when we start centralizing things, we have a single point of failure. But we are a non-profit. We are something more than a non-profit. We are kind of a distributed network of people that think alike, that wanted to do something in some specific realm, and just we look for the way of getting money to do it. Towards, by using grants, by using research projects, but we are more people than the people being paid by the particular project. And this is very interesting, because it frees you from the startup mindset. So I probably, since I knew I was going to be very nervous, I probably took the tips for speakers too literally, but I kind of found it fun. So I'm going to present a kind of an adventure in which we meet the non-heroes, I'd say the anti-heroes, that go on a quest, find some weapons. You can guess which kind of weapons we use. We met some allies in the road. Probably this is the only thing important from this talk, the monsters we are finding, because we are kind of learning in the way. And the adventures yet to come. And my goal here is to convince you that this is important and interesting, and we'd like to have your feedback. Disclaimer. Leap is a highly opinionated project with a highly opinionated team that builds highly opinionated tools, and the talk is given by a highly opinionated person. So don't take me too seriously. When I say something is bullshit, just take it as a shortcut for this is what I think, but I like to, So now you know the team. I'd like to mention that we are not just coders. We tend to forget about the other people in the teams that make that possible. So kudos to the other people that are not sysadmin or coders. We have one woman that the only thing she does is trying to get money through funding research for allowing us to keep coding. And that's much appreciated. So, the West. Already said that. I guess if you're here, it's because you are interested in privacy. And so probably it's obvious in this context that privacy is not for privacy-minded persons. We kind of think that privacy is something fundamental. Privacy and communications are a fundamental human right, and it's about the right to whisper. Privacy, as the cypherpunks said, is the right to choose who I communicate with. And we think that we need to be able to choose who we communicate with when talking with our friends. By the way, this is a very interesting link. In case you don't know it, just click on it and read something tonight. This is the typical thing. Like, okay, we need to do privacy-oriented tools for journalists because they have to keep secrets, what sources and so on. Our saints, the whistleblowers, kind of appreciated in the community, and everybody understands that they need privacy and secrecy. You probably work in a startup environment. If you are in China, doing some wonderful research for selling a big thing, probably you want secrecy, communicating with your CEO to avoid all the Chinese industrial espionage. Or maybe you are thinking about changing jobs and you want to communicate with another CEO and being able to bluff your salary away. How many people here knows this guy? This guy was the one that hacked Hacking Team. Okay? Here you have the whole tutorial about how he did this thing. Let's say I'm interested in interviewing Phineas Fisher. He's probably the most wanted hacker right now that is not in jail. So probably the only way to communicate with him is going to be GPG. How many person here has actively used OpenPGP encrypted email? Good. Now I understand a bit more where we are. Probably I need secrecy to communicate with my lawyer, with my package maintainers. Thank you, guys. But yeah, seriously. When I'm traveling in India, I really would like to, or need to, my mom being able to understand what PGP signing a mail means. Because, if not, whenever I'm going to be kidnapped, because I'm a little white guy with a credit card in my pocket, is going to scam her for money. So, in general, the whole society, the point is that the whole society would need to, if not understand, at least being able to use the magical trickeries that cryptography gives us. And we have fucking failed to do that for the last 30 years. But you get the point by now. We need, our friends is the whole society. Without privacy, the whole society cannot work. You probably, I think you probably remember the crypto wars some years ago. Now we have a very much interesting movie. For those who don't go to the countryside, this is a silo. A silo is something where you put the grain and from there you get the cookies in the supermarket. So we are now in the silo wars. And this is a very interesting moment to be. This is from a Tim Berners-Lee article some years ago. You can see that the cool things weren't so cool at the end. Some of them were, some of them died. Haha. Smart guys. In Dante Alighieri Divine Comedy, there is a very big explanation about the layers of hell. Well, it's an interesting thing with a historical value. We now have a special place in hell, in the technological hell we all live in, for the people that use GPG. And I'm not trying to be smart or metaphorical here. This is fucking real. In my surveillance device, I need to have at least 4 or 5 different apps to communicate with different kind of friends. I don't know if this is the right order, but you get the idea. Some people think that Signal is totally secure. Thanks, Moxie. We can discuss about federation. Some people think that WhatsApp is secure because it has end-to-end encryption. Some people, I don't know why, think Telegram is a cool thing to have. This kind of open source-ish thing. But you know what? This is complete bullshit. This is my rant minute. It's unacceptable that if I want to get a Raspberry Pi from some nice guys in there, I have to get a Twitter account. No. Twitter is not a tool for communication. Twitter is not a fucking protocol. It's a fucking company. You get the point. This guy, Michael Hayden, former CIA director. The most important fact in the last years probably has been, for my biased view, this one. Metadata kills people. And it is not a bunch of nerds that says that. This is the important thing. You were called paranoid 5 years ago. Now, it's not that we think they do it. It's that they fucking say it. So we have a nice pun on the concept of the killer app. They are actually, metadata is actually killing people. But in some sense, we all want to have killer applications, killer libraries, killer operative systems, whatever. And we are all here selling things or recruiting people. And the key, this is from a Snyder book, the key to be in this place is that the things we do in the clouds, the internet, or whatever are convenient and free. Free as in beer, mostly. We believe kind of in free as in freedom, but whatever. The whole open source is thing. And this is a race, my friends. If we want users to use things, we have to do convenient things and kind of free things. So it's like fighting the enemy with their own weapons. And this is the holy grail for encryption and privacy and all that. We all are kind of looking for the thing that does the right thing in the right manner without the user needing to do a fucking PhD to use your tool. And your tool might be many things. Your tool might be infrastructure for sysadmin. How many people here maintains mail servers? So you know the pain, my friends. Things need to be usable also for developers. I'm really amazed by learning so many things about how to make properly usable interfaces for libraries. And at the same time, in the bottom layer of hell, we have the end users, because we are highly opinionated and we tell them what they should think like. So this is what Leap project and its many branches and heads try to do. To attack the hard problems and the interesting problems at many levels, making things so simple that you cannot screw it. I'm not going to talk about the sysadmin part, because that is mostly written in Ruby. No, just because. This is called the Leap platform, and it's for sysadmins to install systems with properly configured defaults and so on. For mail, we also do VPN, but I'm going to focus on mail here. We are kind of sending some libraries, and I'll get there in the second part of the talk, and we have some desktop application for users. Intermission. Usually, people will get out of the talk at this point saying, but the user doesn't care. User doesn't care because we don't make them think that it is possible. We are kind of shaping their view of the world and what is possible for them and not. We also think that the user is not going to pay, but probably the problem is not in the user. Probably the problem is ourselves. I think it was Tancred that wrote a very nice post-mortem on the whiteout thing with secure email, and they basically were putting numbers on how hard it is to monetize the market for privacy. But it exists. People is willing to pay. After Snowden, governments, universities, like whole sets of huge amounts of people were willing to put money on secure email. Yeah, we can discuss what security means, because they probably want to keep their private keys for their citizens or whatever. But the need was there, and the tools weren't ready. So, and there is another thing. Come on, guys, like commoditization goes on many layers. We can put the value on the services and let people earn money through billing for a fucking mail service, and it can be as less as 50 cents a month. If you get 50 cents a month or €1 for 2 months for 100,000 people, you get some nice cash for some developers to code in a Bali beach. So probably the model we want to go is to cooperate in a way that we are not taking only our fishes, but building the tools for everyone to fish and be happy. So in the end, we want crypto, but we want roses too. This is my fundamental truth. I've been 4 years working with email, and I fucking don't know what email is or why people don't use it. And this kind of puts things in perspective. We think that Twitter or Facebook are the big silos, but they are just a tiny spot there on the whole volume of email communication. And that is only a small subset of spoken language. So, come on, it's not going to die anytime soon. I'm going to skip this. If you are the kind of person that don't take this as a fundamental truth, you have statistics and surveys, and you can see the data. So, the weapons. We kind of brought some weapons from our previous. Some people has been like 20 years in this business. And for the client parts and the synchronization parts, we kind of choose Python, because it was kind of obvious. And we were very happy 4 years ago. We kind of were told that all the hard work is done, the crypto is done, you need some glue code, blah, 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 the shoulder of giants. It is really true. And we have the crypto there. And crypto is very effective. It works. And we know that it works because in the leaks about the NSA, we know that there are two things they really get mad at: strong crypto and Tor. So it works. It works for a bunch of nerds. But we cannot explain the whole things that are needed to properly use or to properly be in a key-signing party to the persons. This is what Snowden made to make Greenwald able to have a fucking GPG key. It's an ugly 10 minutes video showing how to use GPG in Windows. It doesn't work. When you have a nerd doing usability studies and doing things for the public, it doesn't work. And at the end, this is how we verify things, because we are fucking lazy. So what if I told you that we don't really need the users to understand the RSA concept? That is awesome, but we don't need it. We probably can have just some layers that do the magic underneath. A very good study 16 years ago showed that the mental models that we have to study usability in crypto are not valid. So we probably kind of have the criminals we deserve. So our plan 4 years ago, in the happy moment of the relationship with the whole project, was this. Very simple. 3 points, glue code, everything nice. Oh boy, how wrong we were. So the thing here is getting GPG key management easy and in a background manner, and put it on the cloud. Because users have multiple devices and they want their GPG keys to be there. Put it on the cloud, but at the same time, we want to put them on the cloud in a manner that the FBI cannot get them when they get a server. And it was like the later part. Okay, we just use the normal mail clients. Simple, right? So we went on a quest, and 4 years later, we have 10 Python packages that are some shit. This is a very good book. It says 2,000 programmers, 3 years, 100 bugs. We now have kind of 8,000 bugs in the fucking issue tracker. And we thought our project was simpler. So we do the key management. I'm not going to talk too much about it here. The logic there is probably 20 lines. Just fetching keys from key servers. They are kind of broke, so we need to figure out a new model for sharing keys, trolling the web of tasks and all that. But yeah, key manager, discover the key, and that's the right thing, trying to establish trust relationships between old keys and new keys, and trying to get scores for how good a key is depending on its source. And we want to kind of share the common parts of it out of lib. So the nice part is, what do you use for local storage? To have your secrets always stored locally in the client and in the server. So it was there, it was done. The only thing you had to do is to hack some setup.py script to do bindings for SQL Cipher. SQL Cipher does transparent AS256 encryption on top of SQLite. Fine. This package is there, it works. We have to merge the Py3.4 because we are fucking lazy, but it is there, it is usable for many other projects. So the important part of the talk, it's called something called Soledad, which is basically the idea of, well, we manage the keys, we put them on a magical library that does the synchronization of data that's being locally encrypted in a way that the server can never tamper with it or infer anything useful about it. The design documents are there, and the code is there. Security goals, encryption in the client side, encrypt the local storage, and has to be resistant to online and offline attacks and to data tampering on the server, because we have to assume the server is malicious. Sync goals, consistency, sync flag, we don't want to sync all the data, has to be multi-platform. We fail at even think about mobile. We are on the desktop part. And these things are in the far future for now. Well, not so much for this. And for usability, we need something that is available, so the user can always get this data. User needs to recover the secrets if they forget the password. And we want to have something general, because we also want to spread this to things like having a pocket application or a to-do application or whatever. So probably something of this sounds similar to what the Ubuntu One guys were doing. So we said, hey, so super nice. They had a library that was basically an abstraction layer to put JSON documents on a storage and sync it. And so we started using it and doing hacks on top of it. Now we kind of have fork, although if the project gets to the life again, we probably can use the old thing again. So we put Couch on the server, and we put SQL Cipher on the client. We have another SyncDB for metadata, and a pool to do things with Key Manager and UPG. The password never arrives to the server because we do something very smart. It's a cellular knowledge thing called SRP. We derive keys to get stronger keys from smallest inputs, and we basically do encrypted blobs and put them on the store, and it syncs. So this is the secrets. The blobs it's just a JSON document with the ciphertext of the original thing. You put it there. You create things. You sync things. Only that. The thing for mail is that we have like the whole mechanism for mail to arrive from the traditional SMTP world, put it on your inbox, decrypt it, do the pieces, and put them on the storage. So you can process your mail on one device and have your already synced inbox in many other devices as long as your GPG keys. And you have a very simple REST API to sync. Allies. We kind of trust on Thunderbird. We wrote a Thunderbird plugin. We have a desktop client that exposes IMAP and SMTP proxies locally. Thanks to all this server was kind of easy and nice to do. Thanks to all these people. And we kind of started collaborating with ThoughtWorks. because they said, oh, this is very nice, encrypted replication of data, so we can put them on a server. This is our client, and this will be the mail user agent. This is the server part with the CouchDB blobs, and what the pixelated project is doing is putting all this in a server and serving a Python user agent that does the webmail. So we kind of put our clients in their server, but we also close the loop and we take the webmail and put it in our local client. So you can do the two things, the corporate mode in which the private keys are in the server, or you can use it shipping it inside a desktop-only application. And it looks like this, and people is really excited about this kind of Gmail-ish things that do all the right magic in the background. Monsters. My biggest regret is not having dealt with complexity before. And that probably comes from our relatively inexperience with big projects and Python and packaging and so on. We start having too many packages. This is fucking unacceptable. Newcomers find it very difficult to understand where each thing is. When you start overloading inheritance, things get crazy very quickly. And we also have some kind of complaints about the whole twisted defer thing for newcomers, which is kind of a religious war. But right now it is very nicely isolated, so people can just use the REST API and forget about the things that are happening in the backend. Another thing that has delayed us a lot is trying to get in the client server thing, in your local daemon, mixing together the Qt paradigm with its event loop, the twisted IMAP server, and some other things, simplify. And we are at that point now, trying to simplify, the thing works, the thing has tests, people is contributed, we have a big company like ThoughtWorks contributing code, but we need to lower the barrier to do a significant contribution to the project in general. And some adventures are ahead. Part of the team now is working in a couple of European Union research grants that have to do with key server validation, key exchange, and trying to tend some bridges across different privacy projects, and we want to share some of the knowledge and even code. And Panoramics is another cool project about doing mixed master networks for privacy. We are one of the first clients in implement a new draft, a new standard proposal, which is called Memory Hole, that tries to attack the design error in mail, in SMTP, that all the headers are going in clear text. And last week we were on the OpenPGP Summit, and it seems that Thunderbird has already implemented this. So the whole idea is that you put all the headers, you put them inside the encrypted and signed mail, and you replace the headers with dummy stubs. So you have a very nice and simple way of protecting the mail while in transit. There are also some nice proposals to do forward secrecy in OpenPGP, doing something quite similar to what the Signal protocol is using, this ratcheting mechanism, to avoid that if an attacker can get some of your keys, it cannot recover the whole, because it is stored, it is there. So trying to break the reconstruction of the whole communications. This is probably going to be something really, really exciting in the next year. And in Soledad, we are in a point where we are not finding any important bugs now, but we need to do some things for scaling. One of the main things we are going to do in the next months is trying to break the atomicity of the syncs, because right now everything is the same pool, and that's kind of shitty. We want to be able to sync all the keys first in a new device, and then probably all the headers, and then probably the attachments on demand. And we have to deal with event inconsistency in a nice manner. There's a lot of things that need to be done, and that's it.
this thing is my fingerprint. This thing is my fingerprint. And for the young people, this is not a Twitter handle. This is something called IRC. We are there, and I'll be very, very happy to talk to you guys and learn all the possible things you can communicate me.
So thanks for an absolutely fascinating talk. We have managed to leave a full 10 minutes for questions. In fact, almost 11, which I think is a great idea. I have a million questions, but you don't want to hear my voice, so I hope you have the same questions in your heads that I have in mine. Who would like to have the first one? Yep.
Thank you very much for the talk. Do you have any idea how to deal with a big amount of encrypted email, how to search in it? What to do with stored away encrypted email when the keys elapse? What to do in the long run?
What we are doing now is that is different in this case. In the original bitmask client, what we do is that we don't store the encrypted blobs anymore. We used the very nice and old code in the standard library it has like 10 years ago, 10 years code that cache the pieces of the MIME tree, and we store all the metadata in different documents in the document store, and we delete the original encrypted blob. So we can do efficient search mainly by headers. Because we can build indexes for searching for the main things in headers. Pixelated project is using a different approach. They are using Bush, I think it's pronounced like this, and they do full text search on the whole body of the mail. And they store, what they do is that they build the index for doing full text search locally, and they encrypt the index, and they store the key for this blob inside Soledad. So you have locally a quite nice and efficient index to do any kind of... We probably could do the same with not much, just trying to block encrypt the things with not much and just store the keys for the encryption inside the metadata database.
More questions? All right, I'll have one while you wait. So I came across an encrypted email client called Mailpile, which sounds kind of simpler but less ambitious. Can you compare the two? Because I felt you were trying to get done in time, which was great. But when you started saying, here, let's have a client in the server and a server in the client, I was lost.
I need probably better diagrams for that. We are really, really similar to Mailpile. Actually, the Pixelated project started to consider using Mailpile for the front end. The thing is that I personally found Mailpile kind of monolithic, and we tried to decouple the things to play nice with the whole provider infrastructure. So Mailpile is probably doing this whole thing in the client. They do their web server thingy, they do all the handling for GPG, and they do the storage, and it's basically the same thing. It's a webmail with encrypted local storage. They don't attack this, as far as I remember, they don't attack the replicability problem. So we kind of started from the upper layer, and this is a very hard constraint. I got Mailpile running with my agent. So at the end, I don't care. We kind of focus on this layer, and the user agent should be pluggable. Mailpile is really, really nice, and for the amount of funding they got, they are really far in terms of features. So I really would like to plug it into the whole Soledad encrypted storage.
Good. Yeah. So the main difference is replication. That's great. Okay. Any more questions? Yes. Ow. God. Oh
Hi. So one of the things I've been struggling with is, can we really escape it? I mean, even if we use something encrypted, people we communicate with use Gmail. Even if we use encryption, if it's on the phone, I mean, that's either Android, I mean, it's either Google or Apple. So can we really escape it? Or is the only way to communicate securely is just, low tech, just meeting people?
I don't think I have an answer for that. It is totally true. Our code now, I kind of screw it. We had code in GitHub, and we are moving to another GitLab instance in which a requirement is that you have an email that is not from one of the big mail providers, because, as you say, it doesn't make any sense. If you are hosting a mailing list server with some pretensions of privacy, and one only person in the mailing list has a Gmail account, end of the game. Have you read Moxie Marlinspike's recent rant about the end of federation? It's a very interesting discussion going on the community, because he thinks that having central control allows you to reach a lot of people, like deploying something. My personal impression is that is not the main goal. Like, federation doesn't really need to mean that you are sharing. Isn't it the open source problem or the cooperative problem in an abstract way? We are open, but the big corporations are less open. So they are open to our things, our code, our conversations or whatever. They can do data crunching, they can do data mining on it, they can make money out of it, and they return zero. I really started being scared about the federation thing when Google closed down the XMPP endpoints, because that means they are fucking going to kill all the interoperability. And for me, mail is important because it is like the last place or common language. It is until now, mail is the only identity, the universal identity anchor. If we lose that, we are screwed. More and more, like with Facebook, it's going to move towards GSM identity pieces. So I don't know, hard question. I want to believe. Sorry?
You said GSM identity pieces? What was that?
What I'm meaning is that right now for all the social networking silos, mail is the identity provider. It's your reset for everything. But more and more, if you look at the peripheries of the capitalist system, they are starting, new people, younger people, doesn't have an email. They only open an email for opening the Facebook account, and they forget the password for the email. And more, I'm seeing this trend about the GSM SIM, the chip, being your identity anchor.
Yeah, your telephone number.
They can build about it.
Yeah, okay. Mm-hmm.
So are you saying that email is the only right way and there's no future for protocols like Signal or something like that?
No, I'm not saying that. Mail sucks. Mail actually is for spam, and we are going to have a big problem about the spam if we encrypt all the metadata, and for work, and for university, and whatever. But this is the pragmatic approach. I'm really excited about things like POM, that have...
What is that?
POM. It's a project, I think, by Adam Langley, which maybe I'm mistaken, but it's like an experiment towards a new messaging protocol with security considerations from the beginning. But right now, it's something that 10 nerds are using. My point with this being strategically important is that mail is going to be there for a while, and we cannot wait. Like, there are situations in the world, like, I don't know, you are running an abortion network in Malaysia. You cannot wait 10 years until the hackers come with the right tool. So consider all this crap I've been talking about some transitional strategy until we can have some decent protocol in place. Has to be open and federated.
And the thing you were talking about was POM, P-O-M?
P-O-M-D.
Thanks.
More questions. What's the time? There you go. We got time for about one more. How about yes?
Hello, hi. Oh, hello, hi. I think one of the things you mentioned in your talk was really important, and it's around the question of why normal people either don't do it or can't do it, and it's around usability. And I think, in the open source world, we have lots and lots of people who are technically very good. We are enthusiastic about pushing the boundaries in terms of protocols and the cryptographic correctness and all the rest of it. And whether it's cryptography and email or whether it's something like LibreOffice, I think there's always a stumbling block, which is the usability for normal people. And it's a shame. I mean, I'm older than most people here. I've seen over the years great ideas which are intrinsically excellent fail because Granny Smith didn't understand the word or the icon looked wrong, something that was relatively easy to fix. So my question is, to what extent are you doing the user research, the user testing with normal people to say, actually, we don't need to put the effort into, I don't know, key replication or whatever it is, because the thing that's stopping people is something else completely, as observed by a more disciplined kind of, understanding of how users interact with what you're building?
Let me search for one little thing. I didn't have time to get into it. This is absolutely important, and usually it is not hard-coded into the processes of the groups. Because we have the engineering bias. We think we know, we think we are gods, we think the users are fucking stupid, and that's a very wrong, I'm generalizing, just trying to be funny, but that's a very wrong approach, and we don't realize about it. I've been talking kind of about mail, but the first part of the project, we were trying to solve another different problem, which was secure VPN. The idea was having a Trojan horse because users are not going to install a desktop client for email, but they probably want a desktop client if it is the only way to get VPN. So now we have our regrets, I have to say, but we spent some time trying to solve the other problem about VPN, cross-platform, and so on. And if you don't know this blog, just subscribe to it. This is Gus Andrews, and she gave some workshops about disability studies in a very scientific way, and came up with a long list of very interesting things that need to be changed because our mental model, basically, for how the user understands and reacts to the application was not optimized. And we fucking need more of these things. Earlier, during, afterwards, and I cannot mention that one of the challenges right now is to close the feedback loop with these kind of things in a faster way.
Okay, that's it. Thank you very much. Huge hand for this, a wonderful security researcher. All right, our next talk starts in a couple of minutes. Well done, man. That was great. Thank you. Next time, practice.
Didn't know you were here. I thought there was no talk manager.
There wasn't.
Okay, right. So you were
I
here.
just did it.
Right. Yeah.
Are you going to do the next session?
I can if you're
yeah,
not.
because I was going to go somewhere else.
Okay. Yeah.
Perfect.
Yeah. Perfect. Yeah, it's all right. Take your time. There are two more. Awesome. It's ready. Take your seat. There's one more. I think it's someone's bag. It's my bag. Oh, it's your bag. I'll sacrifice my bag. You have to sit on the floor. Welcome all. Here we have Eric telling us about building a reasonable popular website for the first time. Give him a clap.
Thanks. First of all, I can't get the screen for configurations exactly right, so I'll do this without my notes. Please excuse me if it goes wrong. So, I'm going to talk about building a reasonably popular web application for the first time, because I got lucky enough into being able to architect, build, and design something that grew quite quickly, and got to learn to deal with scale way quicker than I would have expected. So I learned a lot of this during this time, and I'd like to share what we learned, so hopefully you can at least skip doing the mistakes we did and make your own unique ones instead. So, who am I? Why am I here speaking? I'm the co-founder and chief architect at a company called Hotjar. Hotjar, both the name of the company and our product, is a set of web analytics and feedback tools. So basically this means a lot of data ingestion. We are installed on almost 200,000 sites in the world right now, so a lot of data coming in. I'll give you some numbers later. So my development career actually started a long, long time ago at the age of 6. I wrote my first game. It wasn't that awesome probably in retrospect, but I thought it was. So I got hooked in programming, and I've been ever since. And after that, I transitioned between different tech stacks and throughout the years, but started with Python about 7 years ago now, and it's the one I definitely like the most so far. So, since I'm going to talk to you about something reasonably popular, reasonably big, it's only fair that I give you a definition of what I think is, reasonably big, right? So, Hotjar right now, we process around 400,000 API requests every minute. Our CDN delivers about 10 terabytes of data to our users every day, and we have roughly 3 terabytes of data in our primary data store. It's a Postgres, and another 2 terabytes in our Elasticsearch cluster, and somewhere between 35 and 40 terabytes on Amazon S3. So that's our definition of reasonably popular, reasonably big for today. Still use reasonably standard solutions, though. Our tech stack isn't anything out of the ordinary. As you can see here, Nginx, Memcached, MicroWhiskey, Python, Elasticsearch, Lua, Postgres, and Redis. It works amazingly well to just run a load of MicroWhiskey workers, even at this scale, believe it or not. At some point, we will, of course, start using all the fancy new async.io and UV loop and all these things. It's probably going to be a great match for us, but for now, very plain, process-based MicroWhiskey scales really well. So, now that you have some context, let me start out with what we learned during the last 2 years, kind of. So, log and monitor from day one. This is something we messed up a bit, because we only started logging and aggregating logs once we started having problems. At that point, though, we had so much log data coming in, so we had to spend quite a lot of time cleaning things up before we could actually see through the noise. So start logging and aggregating your logs from day one, and keep your logs clean. Act on the problems you see. Otherwise, you're going to have a mess cleaning it up when you need to, and it's going to be it's kind of a debt as well, not managing your logs. Have a way to profile your API calls. So we ended up using SQL Alchemy as an ORM. It's great, and I love it 95% of the time. But every now and then you have this little innocent line of Python code that causes some really weird query. And having a way to profile both code and database queries is great. We have the concept that our super users, ourselves only, can actually append $profile equals 1 to any API call in the query string. Instead of returning the normal results, that makes the endpoint return C profile data and SQL Alchemy profile data. And having like a easy way to get profile data from a live API call in the live environment in just a few seconds is actually great. It makes your profile a lot more, and you get a much better understanding of your system as a whole. So, highly recommended to have a way to just ad hoc profile a query from a live environment, great to do. Sometimes it's Python code that takes time, sometimes it's, a database, but you'll be surprised how often, the Python code is actually, you do a silly little mistake in SQL Alchemy that's really heavy in processing, so it's a great thing to do. Know when things fail. So at some point, we had to add some cron jobs. I don't remember quite for what, but some background processing. And they failed at some point without us noticing because it was a silent failure. It exited for some unknown reason. It didn't throw an exception or anything like that because we were obviously monitoring for that, but it just failed silently. So it's just as important to know when things are not happening as to know as when, bad things are happening. So we solved this by adding the simple concept of job expectations and job results. A job expectation is something simple, like I expect this job to run every hour. A job result is simply a log entry from the job that it writes when it's complete. So then we basically just have a status endpoint that's called by external third-party service and basically checks that all expectations are satisfied all the time. That way we know that jobs run, and they run on time, and they run successfully. So always beware about safeguarding against things that fail explicitly and things that fail silently. Just as important, and easy to miss. And also third-party systems to monitor your own systems as well, because your own monitoring might fail. So have a way to keep secret. Hotjar, as everything else, started out as an experiment of sorts. So, we weren't too diligent about not maybe keeping external API keys in source control and stuff. In hindsight, stupid of us, but, it is. Then, as the development team grew, we realized, okay, maybe it's not the best idea that everyone has access to all third-party systems, like through APIs, in live environments. So I'd recommend to use something like Ansible Vault or similar, like from day one. It's going to pay off. Because now we didn't. So at the time when we had to start, keeping secrets, we had to change all the API keys, and that in itself was a mess. So have a way to keep secrets from day one. And this is an interesting one. Everything needs a limit, even if it's big. So a good example here is we have the concept of tags. We can basically tag a recording. It's used for, we envisioned it to be used for people saying, okay, this recording, the user visited the checkout page in this recording. However, our users used it slightly differently, some of them. They tagged each recording with unique user IDs coming from third-party systems like Google Analytics. So that meant some users ended up with 400,000 different tags. We showed that in a little nice HTML select dropdown. 400,000 select dropdown options does not render well. Our interface broke terribly because we didn't have limits in it. Users are very creative, and if you give them a way to put limitless amounts of information, they will. And these limits goes for UI, it goes for APIs, length of fields, stuff like that. It also obviously goes for databases, length of fields. Never, never, ever allow unlimited. Perfectly fine to allow really big, but unlimited is bad. If you give your users a way to put unlimited amounts of data in your system, they will, eventually. It took a year, but then it happened. And then another one here is slightly more interesting, I'd say, and much more surprising. Postgres, or data store, uses int4, 32-bit ints, as a default for the ID column. We eventually hit that limit on a table. So we had our 2-something billion rows. That was kind of hectic trying to solve that when everything was down. Because I didn't even anticipate it. Never worked with data at this scale before, but it happened. So think about when trying to design your schema. Try to think ahead, a year or two. I know it's hard, but try. Is there a possibility I could end up with like reaching data type limits if I use this type here? If you think you're even going to be close, choose a bigger data type. It's not expensive, it's just not default, so you have to make a conscious choice. But think about how your data will grow. And if possible, put monitoring in place for this as well. When you're about to reach limits, halfway there, you want to know, so you have time to like plan migration. Don't get too attached to a framework. Right now, we're using Flask and Flask SQL, Flask RESTful, sorry. It works really well. We're super happy with it. But at 400,000 or 500,000 requests per minute, it's starting to have like a significant overhead because most of our requests are like really quickly processed. So the framework matters. This, of course, depends on a use case, but for us, it matters. So at some point, we're probably going to have to transition to something else. So a good advice to minimize the pain of doing that is to use framework agnostic libraries as much as possible. Like SQL Alchemy is a great example because it works, like it has adapters for basically everything, and if it doesn't, easily do one yourself. I don't have anything against using what I like to call thin wrappers, like Flask SQL Alchemy, because it basically doesn't do that much. It's just a nice helper. But if you were to, if you switch away from Flask, you could easily implement what Flask SQL Alchemy does yourself. So thin wrappers, fine. Otherwise, I try to avoid framework-specific libraries. It's kind of like, vendor lock-in, framework lock-in, limits your flexibility. Choose components which allow for language interoperability. So we're definitely mainly a Python shop, but we have about like 0.5%, 1% of our code base in Lua, actually, for performance reasons, running inside Nginx. We did the mistake of using a queuing system called RQ initially. Great system, but Python only. And this caused some issues when we basically just wanted our Lua code to put some simple things in the queue. That ended up being a much bigger thing now because, we couldn't put it there because it was a Python-only queue. So when possible, choose components, libraries, servers, whatever, that allow for greater language interoperability. It makes it so easy if you have like a performance-critical part to just take it out and write it in something else. Plan for database downtime. So yeah, in the beginning, all our database migrations, schema migrations were simple because we had basically no usage and no data. It gets harder, and at some point in time, we ended up, we couldn't just do our basic alter table statements anymore because they started taking significant amounts of time. Fair enough, there are some cute SQL tricks you can do to alleviate some of them. But at some points, you have to introduce kind of a downtime. However, there's a nice trick that helps a bit. Try to decouple data ingestion from data processing as much as possible. A neat way to do it is capture data from the user, put it in a queue, process later. That way you become much more resilient to having database downtime. Even if it's just for a minute, you need to take it down, do a little change. But if you have this queue as a buffer, it's great. It's not always possible to do this, obviously, but it's a great thing to do when you can. So I have a way to share settings between backend and front-end code. We introduced a couple of silly bugs a couple of times, simply because we were lazy. We copied things from backend and front-end. And then we changed one of them, but not the other. And the front-end and backend code didn't agree on values anymore. So this is just silly and stupid, and there's a very simple solution. we ended up having a settings.json file, which contains our shared settings. It's injected using Nginx server-side includes. And that way, Python can read the JSON, and the frontend can read, the content of JSON as well. So super simple. All our shared settings go there, and no more bugs of this kind. So shared settings are good. Duplicating code, we duplicate things like error codes and stuff. Copy-pasted. Now shared settings, not a problem anymore. Have a way to go into maintenance mode. What I mean by maintenance mode is basically a little page saying, we're currently down, sorry. It's not nice when you have to bring it up, but it's probably going to happen to every one of us at some point. And then it's a great insurance having one. We basically have a very little switch to turn on and off the maintenance page. And when doing the maintenance page, be careful and let it have as few external dependencies as possible, because, you probably want to turn it on like when your database server crashed or something. So don't store the switch to turn it on in the database, because it already crashed. That was our first version that did just that. Also on our maintenance page, we've put intercom, communication tool, where people can talk with our support crew. It's a really good idea, I think, to keep communications open with users, even when bad things happen. Feature flags are a great way to test things out before releasing them to everyone. So, at this point in time, we started getting really big and wouldn't want to release things we weren't too sure about to everyone. So we introduced feature flags. We have both server-side and client-side feature flags. So basically, you say, this part of the UI requires this feature, and this part of the API requires this feature. That way, we can do gradual rollouts. We can do beta testing with a limited group of people. And we can also do things like enabling things depending on which type of plan the user is on. So saying, if you're on the Pro plan, you get this feature. So they're a very versatile tool to have if you start thinking in terms of on and off feature switches. Highly recommend, very simple to implement, great thing in your toolbox. Accept different quality of code for different parts of the systems. This was personally kind of a hard one for me, because as a developer you kind of get attached to what you created, and you want it to be super awesome everywhere. But it can't, because then you run out of time. So, for example, we require all our user-facing code to be properly tested, performing well, all these things. However, imagine you have a back office report for internal use. It's okay if it performs so-so, if it takes 5 seconds to generate. It's okay. But think about these things up front before starting to build a new feature. How good does my documentation need to be here? How well does it need to perform? How well does it need to be tested? In an ideal world, everything would be perfectly documented, tested, and perform awesome. But when you need to prioritize, think about it up front. It helps a lot. And these are basically the most noteworthy things we've learned. Kind of not unique things, but surprising things, I'd say, most of them. I'm sure we still have many new things to learn, but this is it for now. Thank you for listening.
Who has any questions?
Why was the SQL Alchemy chosen compared to Django, for example? What were the reasons, and how do you feel about going with Flask so far?
Okay, yep. SQL Alchemy instead of Django, you said?
Django ORM.
Yeah, okay, yep. Well, SQL Alchemy, we actually started out with a different ORM called Peewee. But for some of our very performance-critical things, we needed, we didn't want to go writing raw SQL, that's why we use an ORM. And we felt that actually SQL Alchemy allows you to drop down at a mid-level and still do really advanced queries. And I don't think Django ORM is even, I prefer, I can say like this, 90% of the products you ever do, Django ORM is awesome. But SQL Alchemy, when you really need to do these weird performance optimizations and use very Postgres-specific features and stuff, I found it a bit better. But we could have done it with Django RM, absolutely. However, we already decided on Flask because of simple benchmarking. Flask is quite a lot faster than Django, even if you strip out all the middlewares and whatnot. So we didn't really have a natural tie into Django, if you get what I mean. So, and then SQL Alchemy was a good choice, and I still think it is. Thanks.
Any more questions?
Thanks. Could you get a bit more detail on the implementation of your the maintenance mode page?
Yes.
We're having to do that
cool.
currently.
Yes, absolutely. It's a very simple thing. 30-second background of how our deployments work. We basically push things to Bitbucket, we have the servers pull it and update themselves. So entering maintenance mode is basically, we run the deployment script but through Jenkins, and basically check the box maintenance mode instead. So Jenkins deploys, servers pick it up. This takes about 20-30 seconds, kind of. What they basically do is, during our build pipeline, executed on Jenkins, we actually have conditionals in the Nginx configs, and basically this is simple as like, if maintenance mode, show this page, static HTML.
Any more?
And if I were to add anything to these excellent guidelines, of course there are endless such guidelines, but what had proven to be useful, especially for our company, that would be writing utilities for testing a server, just small clients, because you can write unit tests, but unit tests use prepared environment, not very production made. So if you can just quick run your client in production and test what fails, that is also good. And I think making everything deployable with tools like Puppet, so you can easily just boot a new server and make it build very fast. It is also linked to virtualization.
Yep.
So that is very useful.
Agree.
Cool.
Yep.
About the profiling.
Yep.
So do you use anything else other than having this ability to see the live profiling? Or?
We do, a lot of things. I just picked this because I think I haven't seen it that much before, but we're heavy users of New Relic, and we use pgstat statements in Postgres. It's an awesome thing, very small extension, adds extremely little overhead, less than 1% in most cases, and basically generalizes queries. So independent of query parameters, it like groups queries for you, and it gives like mean execution time average, standard deviation and stuff like that. So if you want to like really find slow queries, pgstat statements for day-to-day monitoring, New Relic, and that's basically it for performance monitoring. Yeah.
How do you limit the profiling only to the staff users, I suppose?
That's simple. You have to log in the system as a normal user, but then we have like it's a super user flag for certain users. We just put in the DB. So that's simple. And the pipe decorator called requires super user. Yeah. So only allowed by certain people.
Any more? Awesome. Enjoy your lunch. Thanks for coming.
Thanks.